Hello dear students, today we will complete our series Algebraic Identities, and this is the sixth part of the series. We have got a special case as well for this identity, so let's start. The learning objectives for the day are: first we will verify that x cube plus y cube plus z cube minus 3xyz is equals to half of x plus y plus z, x minus y whole square plus y minus z whole square plus z minus x whole square. Then we will inspect a special case when x plus y plus z is equals to 0. And finally, we will find the value of sum of cube of three numbers using the identity when x plus y plus z equals to 0. That is, the sum of the given three numbers is equals to 0. So the first task in hand is to prove that the quantities in the left hand side, x cube plus y cube plus z cube minus 3xyz is equals to the quantities on the right hand side, half into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. Over here, the quantities that are there in the right hand side can be computed further, whereas the quantities that is there in the left hand side, it's pretty much done, like it's quite simplified. We cannot do anything with the quantities in the left hand side, so we will go ahead with the quantities that are there in the right hand side. We will compute it, we will simplify it, and then we will see whether that comes equal to the left hand side or not. In the right hand side, we have half into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. Moving on, half into x plus y plus z. And now the quantities that are there inside the square bracket is in the form of a minus b whole square. And remember, we have already done it in part 3 of the series, that a minus b whole square equals to a square minus 2ab plus b square. So we can express x minus y whole square as x square minus 2xy plus y square. Similarly, y minus z whole square can be expressed as y square minus 2yz plus z square. And finally, z minus x whole square as z square minus 2zx plus x square. Now we have some like terms here in the quantities that are there in the square bracket. We have 2x squares, 1x square here and the other x square here. So 1x square plus 1x square will give us 2x square. Similarly, we have 2y squares, 1y square plus 1y square equals to 2y square. And similarly, we have 2z squares, 1z square plus 1z square equals to 2z square. So half into x plus y plus z, and inside the square bracket 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2zx. Now as you can see, we have 2 throughout in the quantities that we have in the square bracket. So let's take that 2 common out. So we'll have half into x plus y plus z. We have taken the 2 common. So inside the square bracket we'll have x square plus y square plus z square minus xy minus yz minus zx. The coefficient 2 has been taken common from all the terms. Now half into 2, that means we can cancel the 2's. 2 ones are 2, 2 ones are 2. So all we have now is x plus y plus z in the first bracket into x square plus y square plus z square minus xy minus yz minus zx in the second bracket. Now we will use distributive property and we will multiply the quantities of the first bracket one by one with the quantities of the second bracket, the square bracket. First, x into x square plus y square plus z square minus xy minus yz minus zx. Similarly, y into x square plus y square plus z square minus xy minus yz minus zx. And finally, we have plus z into x square plus y square plus z square minus xy minus yz minus zx. Now let's multiply. X into x square, we will have x cube plus into plus plus x into y square xy square plus into plus plus x into z square x, or xz square, we can write either way, plus into minus minus x into xy x square y, so minus x square y, plus into minus minus x into yz xyz minus xyz, plus into minus minus zx into x zx square, that is minus zx square. Moving on, plus into plus plus y into x square y, so plus x square y, plus into plus plus y into y square y cube, plus into plus plus y into z square yz square, plus into minus minus xy into y xy square, plus into minus minus y into yz y square z, plus into minus minus y into zx xyz, and finally with z into x square zx square, z into y square z, or zy square, plus into plus plus z into z square z cube, plus into minus minus xy into z minus xyz, plus into minus minus z into yz minus yz square, plus into minus minus zx into z square x. So now, as you can see here, there are lots of terms which can be cancelled out. So let's cancel one by one. First up, plus xy square minus xy square, equal and opposite, so we can cancel them out. Plus z square x minus z square x, so we can cancel them as well. Next, minus x square y plus x square y, again equal and opposite. Next, plus yz square minus yz square, again equal and opposite. Plus y square z minus y square z, plus zx square minus zx square. So we have cancelled all the like terms now. So we are left with x cube, y cube, z cube, and minus xyz minus xyz minus xyz 3 times. So computing the leftover quantities, we will have x cube plus y cube plus z cube minus 3xyz, which is equals to the left hand side. Hence, we have the proof. Now moving on to a special case. If x plus y plus z equals to 0, then we need to prove that x cube plus y cube plus z cube equals to 3xyz. That is, if the sum of the 3 terms is equals to 0, then we need to prove that the sum of the cubes of the 3 terms will be equals to 3 times of the product of the numbers. So let's start with the proof. As we know that x cube plus y cube plus z cube minus 3xyz equals to half of x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. We had established this fact just a while back. Now the special case given to us is x plus y plus z equals to 0. That is, the sum of the 3 terms is equals to 0. Putting the value on the right hand side, we will have x cube plus y cube plus z cube minus 3xyz equals to half into 0 into x minus y whole square plus y minus z whole square plus z minus x whole square. Anything into 0 results into 0, so we will have x cube plus y cube plus z cube minus 3xyz equals to 0, as we had 0 in the product of the terms in the right hand side. So the whole right hand side is now equated to 0. Taking minus 3xyz to the other side, we will have x cube plus y cube plus z cube equals to 3xyz. So we have the proof. That is, if the sum of three terms or numbers is equals to 0, then the sum of the cube of the three terms or the numbers will be equal to 3 times the product of the terms. Now let's solve some questions. The first question, we need to find the value of 15 cube plus minus 7 whole cube plus minus 8 whole cube. Here we have x equals to 15. In place of y we have minus 7 and z equals to minus 8. The sum of the terms, numbers, x plus y plus z equals to 15 minus 7 minus 8. 15 minus minus plus, but sign will remain minus. 7 plus 8 will be 15. 15 minus 15 is equals to 0. So the sum of the three terms is equals to 0. That means we can use the special case. That is, now the sum of the cubes x cube plus y cube plus z cube will be equals to 3 times the product of the numbers 3xyz. 15 cube plus minus 7 cube plus minus 8 cube equals to 3 into 15 into minus 7 into minus 8. 3 15s are 45. Minus into minus plus 7 8s are 56. Doing the product of 45 and 56, the result will be 2520, 2520. So here we have calculated the sum of the cubes without actually finding the cube of the numbers. Next question, we need to find the value of 6 cube plus minus 11 whole cube plus 5 cube without actually calculating the cubes. Here we have x equals to 6. In place of y we have minus 11 and z equals to 5. The sum of the terms x plus y plus z equals to 6 minus 11 plus 5. 6 and 5 they are plus, so let's group them together. 6 plus 5 minus 11. 6 plus 5 11, so 11 minus 11 equals to 0. That means the sum of the three terms equals to 0. So sum of the cubes will be equals to 3 times of the product of the numbers. X cube plus y cube plus z cube equals to 3xyz. So 6 cube plus minus 11 whole cube plus 5 cube equals to 3 into 6 into minus 11 into 5. 3 6 are 18. Minus into plus minus 11 5s are 55 minus 55. Plus into minus minus, the overall sign will be minus. 18 into 55 will be 990. So the question is done. Next question, we need to find the value of minus 7 whole cube plus 11 cube plus minus 4 whole cube. X equals to minus 7, y equals to 11 and z equals to minus 4. X plus y plus z equals to minus 7 plus 11 minus 4. Let's group the numbers with minus sign together. Minus 7 minus 4 plus 11. Minus minus plus, but sign will remain minus. 7 plus 4, 11 minus 11 plus 11. So the sum will be 0. So x plus y plus z equals to 0. So x cube plus y cube plus z cube equals to 3 times of x, y, z. Minus 7 cube plus 11 cube plus minus 4 whole cube equals to 3 into minus 7 into 11 into minus 4. Plus into minus minus, 3 7s are 21, so minus 21. Plus into minus minus, 11 4s are 44, minus 44. Minus into minus plus, so the sign, overall sign will be plus. 21 into 44, 924. So the sum of the cubes has been derived without actually calculating the cubes, as it satisfied the special case. Now, these are assignment questions for you. Thank you and have a nice day.